so if we go back to Ernie here, and if you don't like the entire diagram, you can just put this into a nice simple right triangle. We know 32 feet. The problem tells us the angle of depression is 18 degrees. Where is the 18-degree angle? That's my question. Ernie's looking down at Dinah. Yeah. So is it this angle right here? Is that 18? This one right here. Is that from the horizontal line downward? Everybody wants to put the angle of depression there. Never there. Never. That's the wrong spot. You want to think in terms of, okay, from Ernie coming straight out, he's looking down at Dinah. That's an 18-degree angle of depression out there. So if you're doing it in our little simple triangle, we're saying this one's 18 degrees. Now, your geometry will tell you there's an 18-degree angle somewhere else in this triangle. Because we have what kind of angles going on here? We have two horizontal lines. We got this top horizontal line. We got the bottom horizontal line. We have a diagonal line cutting them. Could it be a transversal? So if 18 degrees is up here at the top, where else is 18 degrees? Down here, yeah. Alternate interior angles. Remember your good old geometry? In other words, angle 18 degrees is the angle of elevation. The angle of elevation and the angle of depression will be the same thing. So it's usually easiest if they give you an angle of depression. I just go put it down as an angle of elevation. So now we need to figure out, the question is how tall is the snowdrift? So we're trying to figure out, I'm going to call this X over here, how tall that side is. And this is where good old Oscar had a heap of apples comes in. We've got 18 degrees. The side we need is that opposite, adjacent, or hypotenuse. That's opposite. We need an opposite, and we have adjacent. So if we need opposite and we have adjacent, opposite over adjacent is which trig function? Tangent. So we're setting this up with tangent of what angle? Of 18 degrees is opposite, which is x over adjacent, which is 32. Okay, how do you solve for x? Times by 32. And then just pull out your handy-dandy calculator, punch all that in at once. Just put in 32 times tangent of 18, and let it tell you what you get. Actually, I don't know this answer. I changed my problem. What's the answer? Okay. They will do, when they do trig problems, when they do word problems, they will do significant digits. So you have to look at how many significant digits were in the original measurements they gave you in the problem. 32 had 2, 18 degrees has 2. You lose the smallest number of significant digits, which in this case, they're both 2. So you round this one off to 2 significant digits. So you actually got what decimal out of your calculator? 10.3 something. Okay, but we can only have 2 significant digits, which would be the first 2. And in this case, it's a 0, but that's okay. We're going to have to round this one off. We would round this one off then to B. He's on a 10-foot high snowdrift. And a couple Christmases ago, we had him that high. So, now I do want to ask you, actually this is more of a calculator question. Suppose you set one of these up, suppose this one had been different, suppose we hadn't known the angle, but we had known the 2 sides, it was a 8-foot snowdrift over a 32-foot distance. How do you get your calculator to find an angle for you? Second tangent, yes. It's actually inverse tangent. So you do inverse tangent of your in your calculator and do 8 divided by 32, and your calculator will produce the angle for you. rose. Anybody who did that? $14? Okay. So you get a 14-degree angle. So you can go either direction on your calculator. If you need an inverse, or if you need an angle, use an inverse. So hopefully those problems won't be any big revelation to you. You've done them a couple times already. Okay, the other kind of right triangle problems you're going to do today are navigation problems, and we have not done these before. What you're going to have right now today isn't bad, because you know we're solving right triangles. You know when you draw this picture, you have to get a right angle somewhere. We will come back late March, early April, and hit more navigation problems. We will no longer be working with right triangles. We can have any angles we want. Navigation can get a little tricky at that point, but right now it's not bad. The biggest problem the navigation is going to play with your brains is 0 degrees isn't in the same spot when you navigate. Got any Boy Scout compass experts here? Where is 0 degrees on a compass? What direction does a compass show you? North. So on a compass and in navigation, 0 degrees is north. Hopefully we go around the circle in the opposite direction. So 90 degrees is over here at the east. 180 degrees is south. 270 is going west. So if I told you to get in your airplane and fly in the direction 200 degrees, what way would you fly? Yeah, you'd be going southwest. 200 degrees would be 20 degrees past 180 here. You'd be heading off this way somewhere. Okay, approximate for me if I said fly from Seneca to Oneida. Take a random, a rough guess about what direction would one have to fly in to get from Seneca to Oneida. Oneida is in what direction? It's northeast. We would have to fly northeast somewhere. If we're sitting here, would it be a steep angle or would it be a fairly flat angle to get out to Oneida? It'd be fairly flat. I guess it'd be somewhere, you know, in that range. Yeah. So it will play with your brain a little bit. I recommend you draw this little compass rose on every problem. Label your 0, 90, 180, 270 so your brain gets used to thinking directions that way, because it will play with your brain. And that's probably the trickiest part of navigation is it just screwed up where we're used to all the angles being. So let us try one. We have a ship that sails a distance of 76 miles in the direction 138 degrees, and then sails a distance of 90 miles in the direction 48 degrees. The key to the thing is getting the picture drawn. What you want to do, make yourself a small coordinate system. I need something that breaks darker. Make yourself a small coordinate system to start from. Okay, the ship sails 76 miles in the direction 138 degrees. So which way did it go if it went 138? 138 is, the compass rose is over there on the right. 138 is going to take me southeast, yeah. So I'm going to go down this way somewhere, 138 degrees. You need to draw these somewhat to scale. I mean, you don't have to be letter perfect, but like if this line is going to be 76 degrees and I'm going to run myself out of space, I can't make it that long. I know this angle up here from 0 down to there is 138 degrees. It sails out that far. Then, when you're going to turn, make another compass rose. Wow, my calibration is bad here. I can't hit this. Okay, make another compass rose. And, okay, now it turns and it sails where? Goes 48 degrees. Okay, which direction is 48 degrees? You're going northeast now. Now, is this line longer or shorter than the first line? We went 76 miles on the first one, now we're going 90. So this one needs to be a little longer. You need, once again, somewhat to scale. You don't have to be letter perfect, but you need to be in the ballpark. So this one's going to be longer. I'm sorry, my calibration is off, so my angles are not doing too whoopee. So that's now, we had 76 miles over here. This one's a 90 mile. And notice, if we just sail, if that was 48 degrees, that means from 0 straight north over here, I didn't want that in that color, that little angle in there is 48 degrees. And so then the first question is, my question is not typed right. How far is the ship from where it started? So if we want to figure out from where it started to where it ended, we have to figure out what's the distance out here to the ending point. And I recommend you put a coordinate system out there as well. Okay. Well, the big question is, right now we know we're doing right triangles. Where's the right angle got to be? Where it turned. How do you know that's got to be where it turned? If it was going 138 and then it went to 48, what's the difference from 138 to 48? 90 degrees. He made a 90-degree turn. So you can tell by the angles 138 to 48, that's 90 degrees. But you can also do geometry and figure it out, which is what we'll actually have to do when we come back to this in April. We'd actually have to go, well, hey, if this whole thing was 138, then don't I know this angle down underneath here, 138 to 180, would be 42 degrees. And by alternate interior angles, the vertical lines on your coordinate system are parallel lines. That means this one in here would have to be 42, which makes the whole thing add up to 90. Eventually, that's how we'll have to work it. Right now, you have the luxury of knowing you got 90-degree angles in there somewhere. Evan, look alive. So now, how far is the ship from where it started? You need to go, it's a right triangle and I have two sides. How can I find the third side of a right triangle? Pythagorean theorem, that's all you got to do. So 76 squared plus 90 squared equals x squared. I'll finish this problem. I think I can make it in 2 minutes. And if you work that out, okay, you're going to get x equals 118. Is that the correct number of significant digits to round off to?
No.
How many significant digits should I have here? 2. We're going to assume the 90 miles is exact. You count that 0 as significant. So if I round that off to 2 significant digits, what would it round to? It would round to 120. So you'd actually say it's 120 miles out. Sometimes rounding off to significant digits can make pretty significant changes in your answer. Okay, this other one wants to know what direction must the ship sail to get back to the start point. Okay, if I am out here on this top right corner, just estimate for me. I needed to go in what direction to get back to where I started? Do I need to go northeast, northwest, southwest? Which way?
Southwest.
You got to go southwest. Well, southwest over here on the coordinate system, southwest means it's got to be somewhere between 180 and 270 then our answer has to be. To know what angle I need to come back here at, I'm going to have to find this angle in the problem. So I need to actually find this angle in the triangle so I can figure that out. And I'm going to run out of time, so we're going to stop this a second.